Welcome to section 6.5. In this video, we are going to be solving linear equations. However, now we're going to do them with fractions. So just to be clear, to solve linear equations involving fractions, all the same rules we've been using, they still apply. The only difference now is that we're just doing it with fractions. That's the only difference. So with that being said, I encourage you to pause the video and try the first example 1 on your own. And assuming you have given it a go, let's work through it. So we have 8/9 equals 2x, or 8/9 equals 2x. So like always, we want to get x alone, or x all by itself. So what we're going to do is divide by 2 on both sides of this equation. So we got x equals 8/9. And then remember, when we divide anything by fractions, what happens is when we divide, our sign changes to multiplication. Let me not write that because I like saying x. So let's just write a dot. So we have 8/9, and then once we get to our second fraction, whatever we're dividing by, this fraction changes. So let's write 2/1 because 2 divided by 1 is still 2. So then we can visualize what we're doing. So remember, when we divide fractions, we have this rule. A lot of times we know keep, change, flip. So we're going to keep the first fractions as is. They're the first fraction. We're going to change the division to multiplication, and then we're going to flip our second fraction. So if we flip 2/1, what we get is 1/2. And then from here, we just multiply the two fractions together. So one thing I will say is that don't forget that there's something called cross multiplication that we can do. And if this sounds foreign to you, I encourage you to go to module 2, which is all about fractions. So you learn all about fractions. You learn how to add, divide, subtract, and do a couple applications with them and learn the different types of fractions. So I encourage you to go to that unit if this is all looking foreign to you. So we're going to cross reduce, so we can divide both 8 and 2 by 2. So if we divide 2 by 2, we get 1. If we divide 2 by 8, then we're going to get 4. 8 divided by 2 is 4. So then here we just multiply cross. So 4 times 1 equals 4, and then 9 times 1 equals 9. So x equals 4/9. That is our answer. Now looking at example 2, I encourage you to pause the video and try it. And now let's work through it. So we have x minus 7/6 equals 4/3. So to solve for x, we're going to add 7/6 on both sides of the equation. So we get x equals, we got 4/3 plus 7/6. So if we look, we're adding two fractions. However, we can't just add them together right now as they are because we don't have a common denominator. So if we remember on how to find a common denominator, in the videos I taught in module 2, we either had two cases. Case 1 is where you just multiply the two denominators together, or case 2 was that we could divide one of our denominators by the other. And in this case, we have case 2, where we can divide, because we can divide 6 by 3. Because 6 divided by 3 is 2, so we get a whole number. So in this case, we can do that. So to get 3 to 6, we're going to multiply by 2. And then from here, whatever we do to the bottom, we do to the top. So we're going to multiply the numerator and the denominator both by 2. So we get 2 times 4 is 8. And then 2 times 3 is 6. And then we're going to add that 7/6. And then from here, we can just combine the numerators. So 8 plus 7 equals 15. So we got 15. So we get 15 over 6. And then we can reduce this fraction by dividing by 3. So we get x equals 15 divided by 3 is 5. And then 6 divided by 3 is 2. So x equals 5/2. Looking at example 3, I encourage you to pause the video and try this one. This one can stump a lot of people sometimes. So assuming you have worked through it, let's go through it together. So you might notice is that we have an x term on both sides of the equation. And one thing I will caution you that a lot of people in algebra make a mistake of is that they say, oh, I can just divide both these terms. This is how this works. And the answer to that is this is wrong. This is completely wrong. This is not right. So the correct way to do this, let me erase all that messiness. I just crossed everything out. So the correct way to do this is, remember in the last section when we combined like terms, if we had 3x equals 4x, we wouldn't divide both sides by 4x. We would subtract both sides by 4x. So we're going to do that same exact thing here because we both have x terms. Nothing changes. We're just dealing with fractions. That's the only difference. So we're going to subtract both sides by 3/4. So these 3/4 cancel. Here, let me write it like this. And then we're left with 4 over 7x minus 3 over 4x. And then we're going to set that equal to 0 because this side of the equation now is 0 because the 3/4 term canceled. So what we're going to do here is we're now going to combine these two together. However, as you can see, we're subtracting two fractions and they don't have common denominators. And in this case, we can't divide 4 by 7 because 4 divided by 7 isn't a whole number or an integer. So in this case, what we are going to do to find, I'm going to do this work up here. So we have 4/7 minus 3/4. So to find a common denominator, what I'm going to do is I'm just going to simply multiply 7 and 4 together. So I'm going to write this down here. 7 times 4 equals 28. So from here, let me write this out. So we're going to multiply this fraction, both the numerator and denominator, by 4 because we're doing 7 times 4. And since we have 4 here, we're going to multiply both the numerator and denominator by 7. So we get 28, or we get 4 times 4, which is 16. And then we're going to subtract 3 times 7, which is 21. So we get 16 minus 21 over 28. And that happens to be 55 over 28. So we get 5 over 28. X equals 0. And then from here, we're going to divide both sides by 5 over 28 to get x alone. And because we're dividing by 0, anything divided by 0 is 0, so we just get x equals 0. And that's our answer. Now, I encourage you to try this problem on your own. And assuming you have worked through it, let's go through it together. So we have 4 over 5 plus x equals 2. So to solve for x, we're going to first subtract 4/5 on both sides of the equation. So we're going to get x equals 2 minus 4 fifths. Now, because we're subtracting a fraction, we have to find common denominators. So I'm going to put this 2 over 1. And we can multiply both sides by 5 to get our common denominator of 5. So I'm going to write that over here. So 2 times 5 is 10. And then 1 times 5 is 5. I'm going to do minus 4 over 5. So now if we subtract the numerators, 10 minus 4 is 6. So we get 6 fifths. So x equals 6 fifths. And looking at example 5, I encourage you to pause the video. Now let's work through it together. So because we have an x or two x's and they're both on both sides of the equation, we're going to want to subtract one of these x terms to the other side. So what I am going to do is let's subtract this 2/3 x from this side. Actually, let's make our lives a little bit easier. So one thing that you can think about too, I apologize, one thing you can think about though, when you're subtracting these x terms or combining like terms, is try to avoid negative numbers. And the only reason why I say that is because the more negative numbers we have, there's just the potential that we might forget one of those negatives or forget a negative sign or drop a negative sign somewhere. So the less mistakes that you can make, the better. So because we want to avoid negative numbers, I'm going to actually subtract 1/3 from both sides, because 2/3 is larger than 1/3. So then we're going to end up with a positive number when we combine both these. And if you notice, this 2/3 and 1/3, they both have common denominators. So we can simply just subtract these two numbers. So 2 minus 1 is 1. So we get minus 1 over 3. Or sorry, plus 1 over 3 x. And we set that equal to 0. And then we're going to subtract 5/3 on both sides. So then we get 1/3 x equals negative 5/3. And then we're going to divide by 1/3. This is a lot of fraction work. That's okay, because we'll get good at fractions. So we're going to get x equals negative 5/3. And then we're going to change that division to multiplication. And then we're going to flip this 1/3 fraction to 3 over 1. And if we look, we can cross reduce. So we can divide both these by 3. 3 divided by 3 is just 1. So negative 5 times 1 is negative 5. So x equals negative 5. And then 1 times 1 is just 1. So x equals, let me write that over. Yeah, we can write it right here. X equals negative 5. And that's our answer. Now looking at example 6, we have a similar problem, sort of. So for this one, actually this example is a little bit easier because we're just going to start off, well, maybe not a little bit easier because we don't have common denominators. But we're going to start off by subtracting 1/2 on both sides. So this 1/2 is going to cancel. And we're going to be left with 5. Let me do this on the side. So we're going to subtract 5/6 minus 1/2 on the side. So we're going to make this fraction have a common denominator with 6. So we're going to multiply 2 by 3. And then we're going to multiply the numerator, because whatever we do to the denominator, we do to the numerator. So 1 times 3 is 3, and then 2 times 3 is 6. So then from here, we just do 5 minus 3, which is 2 over 6. So we get 2 over 6 equals 3x. Now, this actually brings up another huge mistake that people make. When you see this 2 6, you might automatically said, oh, I'm gonna reduce that 2 6 to 1/3. And the thing is, you don't want to do that when you're in the middle of doing other things, right? Because if you think about it, right, if you reduce this fraction to 1/3, when you solve for x, you're actually going to change the value of x. So you don't want to reduce things while you're in the middle of problems. That is one thing to caution, like I caution you against, is that people do it all the time. Don't reduce things while you're in the middle of solving for something. Once you have a problem completely solved, then you can reduce. But because we're not just subtracting two fractions, we're doing more with fractions now. You can't just reduce when you're in the middle of the problem. Okay, anyways, so now we have 2 over 6 equals 3x. So now that we got that, we're just going to divide both sides by 3. So we get, I'm going to write it like this, x equals 2 over 6. And then from here, we're going to do keep, change, flip. So it's going to be 1 over 3 instead of 3 over 1. And then we can't cross reduce because 2 can't go into 3 and 6 means like 1 does go into 6, but that's not going to reduce anything. So there we go. So we got 2 times 1, which is 2, and then 6 times 3, which is 18. Now we can reduce because we already have this solved for x. So x equals 2 over 18. So we're going to reduce that because we are done with the problem we can reduce. So I'm going to divide both the numerator and denominator by 2. So we will get our final answer as x equals 1/9. Okay. We have 2 more examples, y'all. We got this. So for this, I encourage you to actually pause the video if you haven't worked through any of these problems on your own, because I promise you it'll be so much more helpful for your learning if you pause the video and try these problems out on your own before I go through it. So assuming you have worked through it, let's do this. So we have 3 over 2 minus 4/3 x equals 6. So there's actually, so I'm going to subtract 3/2 on both sides. So you get negative 4/3 x equals 6 minus 2/3. So I'm going to do the side work here. Do some side work. So I'm going to do 6 minus 2/3. We can put the 6 over 1 and then multiply by 3 on both sides to get a common denominator. So we're going to get 6 over 3 minus 2/3, and 6 minus 2 equals 4. So we got 4/3. So we get negative 4/3 equals 4/3. Negative 4/3 x, my apologies. And then from here, we're going to divide by negative 4/3. It's going to cancel. So we get x equals 4/3. And we're going to change that division to multiplication. And then we're going to flip this fraction. So we get negative 3 over 4. And then what you'll notice is we can cross reduce both these 4s and get 1 because we're going to divide by 4. And then we can also cross reduce both these 3s and divide by 3. So you got 1 times 1, which is 1, and then 1 times 1, which is 1. And then we can't forget this negative, and then 1 divided by 1 is 1. So x equals negative 1. And then looking at our final example, we can, the one thing to realize actually is, our first thing to realize is that 3 divided by 3 is a whole number. 3 divided by 3 is 1. So we can rewrite this as just 2x minus 1 equals 3/4. Then we're going to add 1 to both sides. So we get 2x equals 3/4 plus 1. I'm going to put this 1 over 1. And then to find a common denominator, we're going to multiply by 4. So we're going to get, we're going to get 3/4 plus 4 over 4. So 3 plus 4 is going to be 7. And then we're going to put that over 4. So we get 2x equals 4/7. From here, we're going to divide by 2. Actually, before I do that, I want to show you all a trick that I should have done a little bit more in the beginning. But we're now in the last example. But this will make your lives a little bit easier. So if you notice, you have like a singular fraction in a linear equation like this one, or we could have done this up here too. I could have made our lives actually easier up here. But now that we're here, I just want to show you all. So if you have a singular fraction, when I say singular, only one fraction in a linear equation, what you can do is you can multiply the entire equation by whatever is in the denominator here. Because essentially what that is going to do is that is going to cancel out the 2 7s. Here, let me write it like this because this will make more sense if I do it separately. So I'm going to multiply this fraction by 7 and then multiply this 2x by 7 because that's the entire equation. So what will happen is that we are going to cross out these 7s and then we're going to be left with 7 times 2 is 14. So we're going to be left with 14x equals 4. And then from here, we can just solve for x by dividing 14 on both sides. So x equals 4 over 14. And if we reduce, we get wait, hold on here. I think I might have made a mistake. I did not make it. Wait, did I make a mistake? We're going to... Uh-oh. Well, I don't know what happened there, but let's let's redo this part. So we're gonna have 2x equals 7 over 4. Oh, that's because I wrote this fraction wrong. I put 4 over 7. So it's supposed to be 7 over 4. So if you caught that before, good job. If someone was here, maybe someone would have corrected me, but I'm alone, so. Okay, good thing I caught that. So we can now cross out both sides by 4, or that side by 4, to cancel out the denominator, and then we're gonna multiply this by 4, because one thing you will learn in algebra or in math is whatever you do to one side of the equation, you have to do to the other, because otherwise, the equation is going to be unbalanced. So you have to balance the equation by doing whatever you do to one side, you have to do to the other. Otherwise, it becomes unbalanced, and then the whole value gets thrown off. So, anyways, 4 times 2 is 8x. We're going to set that equal to 7 because these 4's cancel. So then we're going to divide by 8. There you go. That's the correct answer. See, look, I make mistakes. We all make mistakes. We're all human. So don't feel bad if you make mistakes. Alrighty, there you go. That finished up the video.